Alright, this is our video for 4.1, the graphs of sine and cosine, or the graphs of our sine and cosine functions. This is a useful term, periodic functions. I guess I would know that. These are functions that repeat over some period, or after some given period. These are really useful for things that we want to model with a function that doesn't go haywire. A lot of our typical polynomials will increase infinitely. Exponential functions, increase infinitely. All of our trig functions are periodic, which means they repeat after a given time. There are a lot of things that's useful for. Things that oscillate back and forth, waves, sound waves, light waves, water waves, pendulums, like a perfect pendulum that would swing if there's no friction or air resistance, would swing back and forth periodically. It would hit the same points over and over. If you imagine a point on a wave going up and down and up and down, it's going up to the same height and back down to the same, trough or same height still over and over. So mathematically, that's written like I've got here. So as x increases by some period, so if I've got some random number plugged in here for x, like 5, I don't know, adding the period to it wouldn't change our function value. So whatever we started with, that would be equal to our new function value. It would be the same function value. And same thing for any multiple of our period. So that's nice for us. We kind of knew this already. As your angle goes around the circle, if you've got an angle in standard position, as you go around the circle, you're just repeating your same values over and over. Okay. So for example here, sine and cosine have a period of 2 pi. 2 pi is the length around our circle there. So adding 2 pi to our x value doesn't change anything. So very exciting. That allows us to make these graphs that go out in either direction, left and right, but the y values just oscillate between two given points. Okay. So let's talk about actually graphing these things. We're going to talk about graphing sine of x and cosine of x. Now, we defined in our new definitions of these based on the unit circle, we defined them based on the radian angle, the angle in radians, or the arc length. And that allows us to plug any random number in there. And so we use x for that. X is just any real number. Just like most things we graph, we're plugging in x to our function, and that will give us some y value. So don't confuse these when you see these, the way I've got them written. Don't confuse that with the x's and y's on our unit circle. These x values are going to come from the angle, or in this case, this is why I think it's important to know that the angle and the arc length are the same. It makes a lot more sense to think of this as the arc length. So I've got these two animations for you to watch, and I think just looking at these and playing with them a little bit will do a lot more for you than anything I can say. So let's wait till this starts over. You can forget that part. You see, as I'm rolling out my circle, see that red triangle we start with on the outside of our circle? When it comes all the way around, the distance we've rolled there is 2 pi. So there's 1 pi when we're halfway, and there's 2 pi when we're all the way. So This this horizontal line you see that this thing is rolling on, that is going to be the x value that we plug in our functions. That's going to be the x value on our graph. So as this thing rolls out, so again we're just going to watch it a little bit more. At any given time, you see this red triangle on the bottom here on the this one right here. I forget that I can point at this. It's this red triangle here down at the bottom. It's touching, the point on our rim of our circle. Right. That point is going to be on the terminal side of our angle. Or on the terminal side of our angle. And the x value of our graph is going to come from how far this little red triangle here has moved. The y value is going to come from one of the numbers in our ordered pair along the rim of the circle. Okay, so x value is just this. We roll out, pi, we roll out 2 pi. On this next animation I show you, that is where we're getting our horizontal axis. It's just the distance we've gone along the edge of our circle there. Okay, so next we're going to talk about where does the y value come from. And I love this animation. This comes from Wikipedia, I think. If so, I've used this for years, and I randomly came across the guy who makes this in a forum online. I was like, hey, I've been using your little animation for years, so thanks a lot. So anyway, wow, this is wild. So the angle here, they're talking about in terms of the angle. I kind of wish this had the green. I guess it's okay. The angle, again, at any given point is telling us our x-axis, the y-axis, the point along the y-axis is determined by this green point on the rim of our circle. So sine is the easiest one. It's the least confusing one to look at, so we'll start with that. Now, according to our definitions, sine of our angle or sine of our arc length is equal to y. So looking at your unit circle, the y value at any of these points on our unit circle tells us our sine. Okay. Oops. There we go. Well, look at our green point here. The y value of that point, your y is your vertical axis here. Notice this red point is at the exact same height as our green point, so they have the same y values. So what we're doing here is we're tracing out our x-axis here. We're going further and further along the x-axis at the same rate our little circle here is spinning. So our x-axis being traced out here is equal to this distance we've gone around our circle, and the y value, you see the y value changes from our minimum down here up to our maximum right here, and it's going at the same rate as this point here. So all this is the y coordinate of this little green dot. That's giving us a y coordinate of this little red dot. Again, the x coordinate of this red dot is given by how far our angle has increased, or how large our angle has increased. Okay. Now cosine is the strange one. You notice this blue dot right here? Not the one on our cosine graph. But this one right here moving back and forth left to right, that is moving at the same rate as the x-coordinate of this point, this green point down here. See, the green point goes from left to right. A little blue point goes from left to right. What we've done is we've taken that's our x-coordinate, we've rotated that 90 degrees just so we can display our cosine going in the, so we can display it, excuse me, going, I don't want to say the same direction. We kind of just bent it on our side, so when we graph these things, we can use our x as our angle, just like we did with sine. So this is the kind of crazy one. We took those x values and we made them the y values of our graph. So I wish I had loaded up some more GIFs here, or some more animations. In fact, I think I've got them here. No, that's this one again. Oops. I've got a whole album of these things. Let's see. There we go. Here's one where you don't have it rotating. It's going a lot faster. But the x value here is getting traced directly onto our graph. So that's another way of visualizing this. I should just post a link to this album. Actually, I think if I give you this one link, that will allow you to traverse the album. So I'll add that to our list here. Okay. There we go. Any other good ones? Okay, we'll look at these when we talk about tangent. That one's just good fun. Anyway. So I would spend some time playing around with those. That's probably the best way to get a feel for this. But the y values of our graph, that comes just from the y values on the terminal side of our the y values of the point on the terminal side of our angle. And the easiest way to find those is just look at the y values on this unit circle. Okay. The x values come from the angle or the arc length of the circle. For cosines, again, the x values come from the arc length. The y values come from the x values on our unit circle. So that's kind of strange when you have to wrap your head around where we're taking those x values and those become our y values on the graph. And finally, these things have this maximum value. They both oscillate back and forth between 1 and -1. It's kind of not easy to see on our animations, but you notice they look just the same. They look both the same type of curve, and they are. If you take one of like the cosine curve and shift it over a little bit, or you take the sine curve and shift it over, left or right, you'll get the other curve. So cosine, you can turn it to look, you can make it look just like sine just by shifting it over a little bit. And sine, you can make it look like cosine by shifting it over a little bit. Okay. You can also use your table of exact values, or you can take the points on your unit circle and actually, calculate those, plot them out. So I've got these four major points. I've got them written in radians, but if you want to think of these in terms of degrees, you can do that as well. A pi over 2 is 90 degrees. Pi is 180. 3 pi over 2 is 270 degrees. And 2 pi is 360 degrees. Okay, so if you want to fill in, if you want to see why this kind of slopes up, these y values for everything, say between 0 and 90 degrees, what are those? Those are 1 over 2, square root of 2 over 2, square root of 3 over 2, and then 1. So if you calculate those, you find the decimal equivalents. That will give you each of these points. And you could just continue this around for these other angles. So when you're graphing these, what I've always done is I've got my basic graph memorized. Sine starts at 0 and it goes up to 1, and then back down to 0, and then down to -1, and then back up to 0. I look at just this one period. This is one cycle of the graph, and then it starts to repeat itself. So later on we'll talk about shifting it left or right or up or down, but I always just look at this one period here, starting at 0, going to 1, and then back down. I look at that one cycle because that's the cycle I've got memorized. Right, I know sine between 0 and 90 degrees, or between 0 and pi over 2. I know those values go from 0 up to 1. That's how I remember what sine looks like. The y values of my graph have to go from 0 up to 1. Okay, and then I just know, sine looks like this kind of curve thing. So it goes up to 1 at 90 degrees, or pi over 2, and then back down. Every 90 degrees I hit one of these kind of key points. 0, 1, 0, -1, 0. And then I repeat this kind of wave. And it's periodic every 2 pi, so I've only got this graph to a single 2 pi. If I go another 2 pi, it will have repeated 1 time. If I go another 2 pi, it will have repeated 2 times, and so on. Cosine is exactly the same way, and notice on your graph, I left sine graphed here in red, and now I've graphed cosine in blue. But this time I only put in that one period. Now I know cosine starts at 1 because I've got this table kind of memorized. Cosine starts at 1, and as I go from 0 to 90 degrees, each of these values is decreasing. Square root of 3 over 2, square root of 2 over 2, 1/2, etc. These are decreasing. I guess I could calculate these. That's crazy though. Oh, come on, you can't do that for me, Google? There we go. Square root of 3 over 2 is 0.866, about. Okay. Square root of 2 over 2. Let's see what Google tells us there. .707, so we're decreased just a little bit. 1/2 is 0.5. Now why'd you make that so small? Oh, I know why. And then 0. So you see we start at 1, we go down to 8.5, then 7, then 5, then 0. So these values are decreasing. just like the y values on my graph. They're starting at 1, they're decreasing down to 0. Excuse me. So at 90 degrees or at pi over 2, we've reached 0. And then I just keep going. I go down to -1, and then I come back up. And every 90 degrees, I hit one of these kind of key points. Okay. Now at this point, if I were you, I would pause this for a second and just think about these graphs for a little bit, because I'm about to get into a little bit about how we can play with these, how we can adjust them. So, like I said, I would pause this and make sure you're comfortable with the sine and cosine graph, at least roughly, and start memorizing these things. You should know cosine starts at 1 and goes to 0, and then goes from there, just keeps oscillating. Sine starts at 0 and goes to 1. Okay, so hopefully you took a break and kind of reviewed that for a minute. Now we'll talk about some other graphing techniques. We can adjust the amplitude. Amplitude is how high or low this thing is going very easily just by multiplying it by some number. So right now they bounce back and forth between 1 and -1. If I put some other number in here, let's say I put a 2, now they would bounce back and forth between 2 and -2. So whatever number's in front, we call that our amplitude. So our standard function, just sine of x, cosine of x, that has amplitude 1. Any other amplitude, like if I had y equals 5 times sine of x, that would have amplitude 5. It would bounce from 0 all the way up to 5, so it would kind of stretch out our graph. Let's see if I have a good example of that. So I've got these homework problems. What I would do, let's see. That's easy enough. So these first couple, like 2 and 3, these are just graphs of sine and cosine. Make sure you can pick these out each time. I would probably practice with those two for a little bit. Okay. Don't want to do that one yet. There, so this is an amplitude problem. Y equals 4 cosine of x. 4 is my amplitude, and I know cosine starts at 1 normally and goes down to 0. Now my amplitude is 4. It's going to start at 4 and go down to 0. So that's not it. It doesn't go to 0. That doesn't start. That starts at 0. That starts at negative something. So it's got to be this one. Let me pop that open. And this says my window goes from -2 pi to 2 pi, so 2 periods there, and from -6 to +6. So we're saying this is -6, this is +6, and I've gone up 1, 2, 3, 4. So sure enough, this has got to be the 1. So instead of starting at 1, we start at 4, we go down to 0, then down to -4, and then back up. So that was easy enough. Check answer. Excellent. So if I were you, I would play with these for a little bit. Make sure you can do this. For sine of x, sine starts at 0. So it can't be this one. This one doesn't start at 0. This one doesn't start at 0. This one starts at 0, but I'm going down. That's not right. Sine should go up first. Okay, so I start at 0. I should go up to 4. 1, 2, 3, 4. There we go. That's easy enough. Yay. Now, see, I don't give you, I guess, I don't give you all a lot of homework problems, because if you need more practice, you can just press similar exercise, and it'll give you another similar one. Now, this is the same one. That doesn't help me. But you just keep on practicing similar exercise and getting slightly different ones. So this one starts at 4. It's got to be that. Excellent. Oh, there's finally a different one. So it goes from 0 up to 5. That's this one. Ah, Okay, so there's the amplitude. That's the easiest change. I didn't have one with a negative value. I don't think I may give you one. All that would do is take your graph and flip it upside down. So there you go. Period is probably kind of the trickiest to get, because if you're trying to find each of these values, like if you're trying to find these numbers on the graph, this is going to change these numbers. It's going to either shrink your graph or kind of stretch it out. So our period is 2 pi divided by whatever number is in front of the x within our function. So let's look at an example. I've got this example in your text, but I would prefer just to pull up this homework. Let's do one of these. So this is sine of 6x. So this time it's not a 6 out in front of my function. It's a 6 right next to my x value. That changes my period. It changes it by 2 pi divided by 6. I guess I can do this. Just a piece of scratch paper. There we go. Okay. So all I do is I take my standard period, which is 2 pi. I divide it by the number in front of my x value. Oh, come on. Now that simplifies. Those are both divisible by 2, so I'll divide 2 by 2. It becomes 1. I divide 6 by 2, and that gives me 3. So 2 pi over 6, I took my period of 2 pi, divided it by that number in front of my variable, divided it by that 6, and I get pi over 3. So how does that change? This is my new period, pi over 3. What did that do to my graph? Well, my normal period is 2 pi. Which one of these things is bigger, 2 pi or pi over 3? Hopefully you can guess just from looking at this. Well, I took 2 pi and divided it into 6 pieces. That gave me this pi over 3. That means each one of these, this is 1/6 as big as 2 pi. This should be a lot smaller period. So it's kind of weird here. This whole number, 6, kind of shrunk my period. Now, instead of repeating every 2 pi, it's going to repeat every pi over 3. Okay, so which one of these graphs would it have to be? Well, in this case, I don't even have to know the specifics. I just need to know that sine normally goes from 0 to 1. This is the only one that starts at 0 and goes up to 1. I'm going to zoom in anyway. So the y-axis, they're counting by 1/2 for some reason. I don't know. So 1 is right there. We've gone from 0 to 1. And this thing finished right here. Is that pi over 3? Well, if this whole distance is pi, then a third of that distance would be about there. I mean, that makes sense, right? We got 1, 2, 3, 4 tick marks, so we'd had to gone 1 and a little bit more, or 1 and 1/3, in order to complete a full period. So that's actually not too bad. Sometimes it's going to be tricky with how MyMathLab decides to label their axes. In an ideal world, they would label each of these tick marks, and they would label each of these kind of key points. Okay. But they didn't. You just have to know, well, if I take pi and divide it into 3 parts, that's about 1 and 1/3 each. Okay. Let's see if I have another one. No, I guess I should select this one. Okay, cosine of 3 pi. Again, we take our period and we divide it by this number. So dividing it by 3 means this graph should be about 1/3 as large. So but again, they're using pi as our tick mark here. That's strange. So let me blow up this graph here. So in this case, instead of 2 pi over 6, in this case, the number in front of our variable is 3, so we're just taking 2 pi and dividing it by 3. That gives us this, 2 pi over 3. So if you're to divide this x-axis, which goes to a total length of pi, if we were to divide that into thirds, we'd be going 1, 2, 3, 4. Since you got 4 tick marks, we would be going 1 and 1/3 each time, and we want to go 2/3 are our tick marks. We would go 1/3, 2/3. So I'll save my best score. So we only got a couple of these where it asks you to do I may just have that one where it asks you to find the period. But it's not too bad. Normally what's going to happen is you're going to have a whole number here. Dividing your period by that whole number, well, it just means you have a smaller period. Instead of going up to 2 pi, you're going to go to some fraction of pi. Okay. What else do we have here? That's another example from your textbook. I mean, there's explanation given in the textbook, and I've got my explanation written out here. If you want to take a look at that.